everyone. Welcome to Intel's session at SUSECon. My name is Jack Ellis, and today I'll be talking about the latest Intel silicon products available today, their new features, and how they're enabled in SUSE products. So we're going to start in the data center here. So just want to set a bit of context. When we look at the data center requirements today, what we see is a lot of competing interests between performance and energy efficiency. So just starting with the left side of the slide here, AI, obviously a very important topic right now in the industry and for a lot of our customers. No surprise, AI is unlocking a lot of new opportunities, benefits, productivity, time, cost saving, etc. AI means performance, it means GPU, it requires high throughput and low latency. Other workloads, similar workloads such as SAP, partly the same. If you have a lot of concurrent users, throughput and performance becomes important too. Security, quality, reliability, of course, very important. Nobody wants crashing servers in the data center, and people, especially for cloud use cases, are looking for security that confidential computing can provide. But these requirements also conflict with other organization goals, right? So, such as efficiency, sustainability, and power consumption. It's very hard to strike a balance between two. So as you can see, organizations are having to compromise in order to reach their business outcomes. So it's not easy. And from a hardware vendor and CPU perspective, we have to find a good balance between these competing priorities. So an interesting development in the industry has been the evolving perspective on CPU architectures. There are, so-called power cores and also known as performance cores or P cores, which offer excellent multi-threading capabilities for intense workloads. These cores provide high frequencies, making them well suited for demanding tasks such as generative AI or analytic workloads. On the other hand, there are efficiency cores. These cores are often used for high density workloads or cloud native applications where simple single-threaded tasks are common. For example, a container running a small JavaScript application on top of Node.js can scale out by adding more containers rather than increasing frequency of a single thread, as would the case be with something like SAP NetWeaver. So it really depends on how the application is built. P&E cores have been in the industry for a short while now. Laptops and desktop computers have incorporated this architecture for about 2 or 3 generations, with Intel core desktop CPUs featuring both P&E cores. So to explain this in a simple way, I guess how they sort of work, if you're running a laptop on battery and the performance you need to be handled by efficiency cores, you'll get a much longer battery life, right? Rather than if the work you were doing was being powered on the performance cores, this would obviously consume more power and be less efficient. So here's just another view on my earlier point about P&E cores, just to give people, a better understanding of how, very roughly at a high level, workloads are split between P&E cores. It's not entirely black and white, but this does provide some insight. For example, modeling and simulation, which is a high performance compute use case, is definitely more of a P core use case. Whereas, as I mentioned before, many cloud native applications, which are often simple and single threaded, are standard E core use cases. Again, it's not entirely black and white, but this general example just might help you get a handle on it. Another example, in areas like networking, media, and gaming, where there are significant performance requirements such as rendering, P cores are typically used. So, and on the other hand, network, microservices, 5G, and telecom use cases could potentially be handled by efficiency cores. However, it really depends on how the software is developed, what language it's using, what runtime, and so on. So just, rough idea, a good snapshot of just how to break it down by Intel's CPU offerings. So the latest product line for Intel Xeon, which is designed for servers, is Xeon 6. The Xeon 6 processor is versatile, supports a range of applications from AI to microservices, features a modular x86 architecture with options for performance cores and efficiency cores, allowing for tailored configurations to meet your specific workloads. These processors offer significant, performance improvements over previous generations, more cores, increased memory, bandwidth, enhanced I/O capabilities. They support the latest DDR5 memory and advanced I/O technologies like PCIe Gen 5 and Compute Express Link, ensuring efficient handling of demanding workloads. Efficiency is probably one of the key strengths of Xeon 6 family. One of the highlights, providing scalable performance per watt. This makes them both powerful and cost effective, ideal for data centers looking to reduce operational costs and energy consumption. Of course, security features as well. So security features such as Intel Trust Domain extension and Intel Software Guard extensions ensure robust data protection as well, helping you comply with privacy regulations. So in summary, Intel Xeon 6, compelling combination of performance, efficiency, and versatility. Great choice for modern data centers and helping us address some of the challenges I touched on earlier. So just from a client computing perspective, just briefly touch on this. The latest products we have in the market are from Intel Core Ultra 200 line. You might have heard about it in the press or at CES in January. This line offers really competitive run times for laptop designs, especially for ultra-mobile devices with Arrow Lake and Lunar Lake designs. For performance notebooks, we have CPUs that deliver high performance, ideal for CPU-intensive workloads such as machine learning, video encoding, and database management. For desktops and workstations, we have the Arrow Lake designs, which come with more cores, provide more power. These designs have larger energy envelope, meaning they can access more power in terms of watts. So that's the latest line from AI PC Portfolio 2025. Just from a network and edge perspective, the business unit or use cases rely on Xeon and the Intel Core CPUs that we talked about earlier. There are dedicated CPUs available for specific needs, such as those with real-time extensions or acceleration for telco use cases. Customers with low power requirements, the Atom line is still available and suitable for applications with minimal compute needs. Intel offers a broad portfolio for customers to explore, including network cards, smart NICs, and Intel IPUs, whether for standard Ethernet designs or more advanced needs. Additionally, we provide Wi-Fi and 5G chips, both from Intel and our partner ecosystem. So it's a small snapshot of our network and edge offering. And of course, AI being a big topic. So from an Intel perspective, our new product in the market, Gaudi 3. This is an AI accelerator, not a GPU. This makes it quite different from other products out there. We see Gaudi as a very competitive product against other products in the market for standard models. Intel provides a lot of benchmarks, and the Gaudi card relies on standard technology like Ethernet for scaling out. This benefits of this means there are no third-party components needed to connect multiple Gaudi units or clusters in servers. We also have an initiative called OPIA, short for Open Platform for Enterprise. I will touch on this a bit later, but it just shows our sort of commitment in open source frameworks as well. Unlike some companies where it's a lot more sort of closed source solutions, we're working with organizations like the Linux Foundation to drive more efforts in here and make it more accessible. Many of the models we've tested and optimized are available on platforms like Hugging Face. Intel also provides optimized frameworks like PyTorch, which are usually available through the Intel website. Just wanted to quickly show just the performance improvements versus the previous Gaudi product. So as you can see, significant improvements and a strong competitive product. If these are interesting to you, obviously, please do have a look on our website to read more about Gaudi. I've only just got the high level sort of stats on this. So now let's talk a bit around SUSE enablement. So everything we've discussed so far is actually pretty much enabled in the latest version of SUSE Linux Enterprise Server, which serves as a base Linux OS. SUSE on Xeon 6 has been supported since launch. Most Intel Core CPUs are enabled too, although there are a few patches that will still be included in SP7. Same goes for Xeon 6 in specific use cases like telco, which require very specific network drivers and support for certain accelerators. These updates are expected to come in SP7. SUSE is always on top of things, essentially. Yeah, I think SUSE product has enabled what Intel has put upstream. But for any code that remains out of tree and isn't accepted by the Linux community, there can be a delay. But however, for specific network drivers and use cases, Intel and SUSE collaborate closely together to enable them. Through the solid driver program, they provide access to these drivers and ensure they're tested. So end customers don't have to spend time on testing and integration themselves. So there's quite a lot of work happening in the background here to make this all possible. But hopefully this just gives you a snapshot of how closely SUSE and Intel are working together from an enablement point of view. So let's talk a little bit around some key workloads. So SAP remains very important. Many on-premise SAP HANA deployments run on top of SUSE. Last year at SUSECon, we discussed some exciting news. The KVM validation, which we discussed, now in place. SAP has certified the performance of a HANA server running in a virtualized environment on top of KVM, the open source Linux hypervisor, and SUSE Linux Enterprise. We've achieved the 2-socket validation, and we're expecting the 4-socket validation to come relatively soon. This is for one VM, and multi-VM validation is also expected to come quickly, so we should be in a good position here. The latest Xeon CPUs are also highly relevant for SAP workloads. They bring more performance and more addressable memory, which means customers can either downsize their systems or have more room to grow. If they invest in a Xeon 6 system now and it's not fully utilized, they can grow much further than with previous generations. This means having more addressable memory, larger database sizes, or if they virtualize, they can move more systems onto one box or move from 4-socket designs to 2-socket designs. So you get the point. And we expect these advancements to continue with the next upcoming generations too. Telco, another area where we collaborate quite extensively. SUSE has announced their ATIP solution to address the needs of telco service providers. It has been validated on Intel hardware. Currently, there's also ongoing development work to fully enable Granite Rapids D. As I mentioned earlier in the network and edge section, there's a variant of Granite Rapids, which is Xeon 6 with P-cores, specifically designed for telco use cases. This variant includes a set of specific accelerators for network and telco applications. Support for these additional accelerators is expected with SP7 of SLES 15. This work is currently underway, and customers who want to test this should be able to do so very soon. Another project that Intel is driving right now is FlexRAN. So in the past, telco networks relied heavily on dedicated hardware, appliances built by companies like Nokia. However, there's a trend in the industry to move towards software appliances and containerized solutions. So basically, this is what FlexRAN is doing. It's a framework and reference implementation provided by Intel, which SUSE has validated. The test results are available on both the SUSE and Intel websites, along with instructions on how to set up a FlexRAN environment. AI, obviously a super interesting use case and workload for everyone. There's a lot of demand in the market right now, and SUSE has its SUSE AI in place, and we're working closely together on this. As I mentioned earlier, Intel's AI hardware accelerator is Gaudi. The Gaudi driver and the entire software stack has been validated by Intel for SLES SP5. You can find the installation guide on this slide. For inferencing use cases that don't need an AI accelerator or a GPU, and there are a lot of those still. Xeon 6 is a great platform for this. If customers want to get started without a big investment and no training requirements, they can. There's plenty of material available on the Intel website to help you understand which model sizes perform well and how they compare to a GPU. We've also been discussing Intel optimized libraries. I mentioned them earlier. Intel offers optimized versions of Python, PyTorch, and TensorFlow. Of course, we have upstream. We still have these versions available for download. And while some optimizations might be turned down by the Linux community for broader platform compatibility, these libraries are still very useful. I also briefly mentioned OPIA earlier, so Open Platform for Enterprise AI. Intel started this project and it's now a Linux Foundation project. Best way to think of it is a reference implementation for a rack-based architecture and use cases. It's fully open source and customers can download and deploy it. We're working with the SUSE AI team to test OPIA, and SUSE is considering joining the project too, so we'll see where that goes. There are already some big names that have joined OPIA. If you're interested, you can check out the website at opia.dev. For example, SAP is one of the companies that has joined OPIA and is exploring its potential. And then just to wrap up this presentation, so I just want to talk a little around confidential computing. We've been discussing this for quite a while, focusing on Intel TDX or trusted domain extensions. Intel has been working hard on upstreaming the TDX patches. The community has been consolidating efforts, especially with AMD Sev also in the market, aiming to unify on one kernel AVI stack, which makes a lot of sense. This required some rework on our end, causing a bit of a delay in getting the TDX patches accepted upstream, but we're now in the final stretch to provide customers access to TDX. We provided a drop of the complete TDX patch set on the 6.11 kernel. Backporting is currently underway, and we expect SUSE to make the confidential computing module available very soon. Customers who want to test it can install it via the module concept, enabling the confidential compute module and pulling a dedicated version of the kernel with the TDX patches plus QEMU with the TDX patches. This should allow customers to move forward and test it. There are a few more interesting aspects as well. During last year's SUSECon presentation, there were questions about what happens when data is moved to a GPU. While data is encrypted in main memory, it becomes unencrypted on the GPU. A standard called TDX Connect is being established to address this, and implementation is underway from both our end, from our end and the GPU card providers. We expect this to be available in the near future. Another big requirement we've heard is live migration. This is quite interesting because a dedicated key is generated by the TPM on one server, and if you live migrate a VM, the key needs to be securely transferred. This is an interesting intellectual challenge, but still solvable. So we have solutions to make it work, and we are working on that. So, and with that, I wrap it up. Thanks everyone for giving up your time to listen to this presentation. I hope you found the call useful and enjoy the rest of SUSECon. Thank you.